Hello, welcome. We're looking at electrochemistry. Again, we're at part 8. So this time I want to sort of go into the electrolysis of water. We've been talking about how electrolysis or electrolytic cells is the idea of turning back using electricity, a non-spontaneous electrochemical reaction. One of those is water. Now this is an important one to sort of understand because we have things called fuel cells and hydrogen cars and these kinds of things, and it uses this process where it actually does the reverse of it, which is spontaneous, and of course then that creates current through this. But this is splitting water, and splitting water takes energy. The water doesn't just split into its components on its own. So you can see what's happening here is you have your anode and your cathode, and we have our anox red cat. We could go ahead and write that out here. Let me get this right here. So our anox red cat applies here, right? And so at the anode we have oxidation. So here's our oxidation right here. Our oxygen is getting oxidized. It's losing electrons, and our hydrogens are gaining them. So that's turning into hydrogen gas, and we got water turning into oxygen gas on this side. So right here at the reduction, the hydrogen gas, we're going to ask this question of what volume of hydrogen gas will be collected at 30 degrees Celsius, 720 torr, and 2.50 amps for 1 hour. So where do you start with something like this? Well, let's start right here. Here's what we find out. We find out that for every one hydrogen gas molecule, 2 electrons are used. Okay, so let's go ahead, and I've already worked out some of this for you. Let's go ahead and take some of our previous learning and apply that. So our total current is going to tell us in our time, we could actually find out our total amount of electrical charge, which is our coulombs, right? And we could use that to figure out our total moles of electrons transferred. And then, like I mentioned just a second ago, we have 2-to-1 ratio right here at our cathode. So 2.5 amps equals Q divided by the total time. Time is 1 hour, so that translates out to 3,600 seconds. So multiply this by this, and you get 9,000 coulombs. So the amount of moles equals the total amount of charge in coulombs divided by Faraday's constant. Faraday's constant being 96,485. So we're going to go ahead and divide this out, and we find out that we have 0.093 moles of electrons. Now, for every 2 moles of electrons, 1 mole of hydrogen gas is formed. And we're actually looking for the volume of hydrogen gas, so we need half that amount of moles. So we divide the 0.093 by 2 to figure out the actual number of moles of hydrogen gas. So now that we know the moles of hydrogen gas, how are we going to figure out the volume? Well, I've got number of moles, I've got temperature, and I've got pressure. So we could use the ideal gas law, which is PV equals nRT. So I'm going to go ahead and throw that up here real quick and move this over here, and we'll take a look. So PV equals nRT. So my pressure is 720 torr. Put that in here. I'm solving for my volume. That's my unknown. I know that I have exactly 0.0466 moles of hydrogen gas. I know that my R constant for torrs, is 62.4. And remember, you have to keep in mind what your pressure is measured in to know your R constant. So 62.4. And my total temperature is 30 degrees. We have to use Kelvin in the ideal gas law, so we change that to 303. Multiply here and divide by this, and we get a total volume of 1.22 liters of hydrogen gas produced in this electrolysis situation at 722 torr and 2.5 amps for 2 hours. So there you go. You have a pretty easy way to calculate exactly how much hydrogen gas you'd be producing and oxygen. So if you were using this for a hydrogen car, you'd want to load up your hydrogen car with your hydrogen here. It's going to pull oxygen out of the air, it's going to make water, and that's going to be the opposite reaction to this, which is spontaneous. So you're going to generate electricity, which is what runs your car. So kind of the theory behind fuel cells. So an important thing to know, and this is kind of a fun way to work it out.